Hi, let us understand the architecture of Kubernetes. Let's assume I do have a node where the container runtime is installed. In our case, let's assume it to be a Docker container runtime environment. It could be the other container runtime environment like CRI-O or Rocket as well. Now let's assume I do have a Docker container runtime environment. It's called a node. And like this, I can have n number of multiple nodes running parallel and connected over the network. When I do have n number of nodes running together, managing that would be a difficult task. So I need a machine which can manage the environment or all the machines. We call this as a master and others as a worker. Together, we call this as a cluster. And all the worker needs to report to the master. The master needs to store all the information persistently in terms of like what are all the workers, what is deployed in each worker, and the information on what needs to be done, when it needs to be done, how it needs to be done. All information needs to be stored in a database. So it will be having its own database. I can have multi-master as well for high availability, that we will discuss it later. And every worker will be reporting to the master in terms of its current status as well as its resource utilization, what are all the containers running within it, and its status. Basically, the entire metrics will be reported to the master. To call this as a Kubernetes cluster, we need the components of Kubernetes. So basically, every cluster needs to be interacted by the client from outside world. Either it could be a client or some other machines, or internally the communication needs to happen, and accepting this communication is done by a component called API server. API server, that will be a single point of contact for any interaction from the client or even from the worker. The interaction will be through the kube-api server. And as we discussed earlier, the storage, it's made of etcd database, which is a key value store database where it is going to store all the information related to this particular cluster and the applications deployed. And every worker will be having a component which is called kubelet. A worker cannot interact with the API server or report the information to the master. So we need a component in each host that is called a kubelet, so that it can communicate the information how the kube-api server is expecting or the other components that are available within the master. And once the communication is received from the kube-api server, the master needs to take decision on what container should run, where and how. For that, we do have a component called controller. That's like a heart of the entire cluster, where it is going to control the entire cluster on what that specific node can do and what are all the container it should run and what is its status, how it should behave. So all such informations will be controlled by the controller. Once the controller decides if any new container needs to be started, where it should be started, it will be requesting the scheduler, or with the help of the scheduler, the container will get started within the containers. So basically, we are going to have n number of containers running within each and every host. And all these containers will not be running as it is, it will be wrapped within another component called pods. So basically, we are going to have a pod, and the pod will be controlled by the kubelet. So pod is nothing but a collection of containers, how that should be managed. Like this, we can have n number of pods running in each and every machine. So it's a quick revision. This is how it happens. The cluster will be communicating with the external world or to the client, and the internal communication will be happening through the kube-api server, and the controller will be acting like the heart of the entire cluster, where it will be controlling the nodes, pods, everything it will be controlling. And scheduler, it will be taking the decision on what pod should run in which node and what type of container should be running within it. All such decisions will be taken by the scheduler. And a kubelet will be running in each and every host, which is like a master for that specific node, and it can take the decision how that particular pod should behave and what are all its status, and it takes the responsibility of reporting the status of the node or the individual pod or the individual container within the pod to the master. And we do have a utility tool called kubectl, which helps the client to interact with the cluster. So to have a working condition of a cluster, we need to have a master, worker, and all these components deployed, and we need to have the kubectl to interact with the server. We can have all these components put in a single machine, and we call that as a single node cluster, or we can have this way of distributed cluster as well.